Welcome to the Experience with SUSE Enterprise Storage session. My name is Martin Weiss. I'm working as a consultant at SUSE. And unfortunately, Robert Großschopf, the guy who wanted to present together with us, the system engineer, felt ill and is in his bed at the moment. So the nice guy over here, Orhan Alici, is trying to jump in and assist a bit because I'm not sure if I can cover all the slides from Robert properly. And last but not least, we have Joao with us, who is one of our famous engineers in the SUSE Enterprise Storage area. And we three want to cover that experience that we had made with SUSE Enterprise Storage over the past year, roundabout. And now let's dig into it. So, three things that we want to present to you. The first story is about the introduction about SUSE Enterprise Storage. We say it's more the pre-sales phase, so before the customer buys the licenses and the subscriptions, and the phase where we do the proof of concept. So we give a brief overview about Ceph, what it is. Before digging further into that story, who is already using Ceph in production? One, very good. How many years? Okay, wonderful. Maybe we can change. You can come here and explain about your experience. All right. Yeah, then we come to the topic about the experience, especially I myself had during implementation at different customers. I want to explain a bit what customers we had so far and what we did there with Ceph. And finally, after we have done the implementation, the operations and troubleshooting starts sometimes, and that's when Joao is going to jump in and take over. Pre-sales phase. So what is SUSE Enterprise Storage, where it's coming from? Originally, it's really, really old from the agile world that we are living in at the moment. Sajewile started with that topic 2003 already, so it's around about 13 years old now. And initially, his thought was to build a file system on top of an object storage. That was the initial thought. Funny that this is the last thing in the story that we get now this year. So the major reason was that the OpenStack community was putting a bit of pressure on the project to support block device layer, so that got more priority and more attention before finally we could take care about the file system CephFS. And thanks to version 4, we officially support that now in production environments also. In 2013, we as SUSE announced that we're going to productize SUSE Enterprise Storage. And a year later, Red Hat then decided to buy Inktank, which is, in our opinion, a good thing, because now we have multiple vendors working on the same projects. And they also did not acquire full Inktank. For example, we have one of the Inktank guys here with us, and there are also others. Yeah, that's a bit about the history. In 2015, we delivered the first version of SUSE Enterprise Storage, and what I want to show here is the rapid development and delivery of increased version numbers and newer versions that we delivered here. Our plan is, and we deliver on that already, to have every 6 months a new major release. Why do we do that? We do that to deliver newer functionality as soon as possible and to bring added value to every customer. You don't have to be afraid about that, because whenever we increase the version, we can upgrade more or less online. We don't have downtime during the upgrades. So implementing the new functionality and using it is pretty easy then. By the way, if there are any questions while we are talking about these things, don't hesitate to ask. Okay, what were the criteria when Sajid developed Ceph? So one of the most important things was for him to develop a system that is fault tolerant per default. So we don't have any component in the system that is not fault tolerant per design. We have no single point of failure. We have pure scalability, so the target is to have each and every component in a scale-out manner. That means instead of having one, I just add additional ones, and with that I get scalability. The system itself is designed to be self-maintaining and self-healing, so if there is any failure in any place, the system always has the priority to repair himself and heal. And because it's software-based, we have a lot of flexibility in the system. We can do changes to adjust to different or new workloads whenever we want to. The system delivers multiple access protocols. We have the iSCSI, we have the file system layer, we have the block access layer, the block layer, we have the we have Swift and S3 access protocols. Now we have the file system, and in the future we will also add further access protocols like NFS and, oh no, NFS we have already, I think, as a tech preview, right, Lars? But also Ceph access is in the pipeline. And most important, compared to classic storages, it runs on commodity hardware. So you can take a server off the shelf, install it, and use it as your storage in your environment. But when we're talking about commodity hardware, this is not what we are talking about. So please, 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 when you're going to touch SUSE Enterprise Storage or Ceph, and you're deciding what hardware you're going to use for it, don't take the really old one in your environment, because that will not fulfill most of the performance requirements you might have. So yeah, you can use commodity hardware, you can use old hardware, but it depends. On the other hand, the question is, does it make sense to have huge, big servers that have a lot of JBots attached? It's possible to do that, but in the system, if then one of these servers fails, it has a very big impact. So we have to deal with the situation where we have to decide how many disks do we want to have in each component of my cluster in the end. Do I want to have one or a few servers with a lot of disks, or do I want to have many servers with not so many disks? It's always a impact then on cost and usage when such a thing fails. So also here, it depends. And that's also one thing I want to mention in general. Whenever you deal with Ceph, it always depends, whatever you're doing. The great thing about our technology here is we have a lot of flexibility compared to classic storage systems where you just have to take what the vendor gives you. So we get the flexibility. On the other hand, you have to decide a lot of things that the vendor normally decides for you. So that's a different thing. You get flexibility, but you have to deal with it and decide your own. A few acronyms when we're talking about Ceph. We have the RADOS layer, that's more or less the internal communication protocol. We have the RBD, which is the block device, when we're talking about block devices in the cluster. We have the RADOS gateway, which is the S3 or Swift access. We have the Cephfs, which is the file system. We have the OSDs, which are the object storage daemons. You can think of each and every hard disk you have in the system is managed by one of the object storage daemons. And you can have object storage hosts that have multiple daemons per disk, or one daemon per disk. We have the Ceph monitor that is responsible for maintaining the membership in the cluster. So this one is more or less the cluster functionality to monitor which disks are there, which are not there, and the clients find out due to communication with the monitor what is there, where do I have to talk to. For Cephfs, we have also the MDS, which is the metadata server. And most important here, most of the intelligence within the Ceph system is depending on the crush map. The crush map is, let's say that's a configuration that outlines the architecture and the structure of your cluster. And based on this crush map, every client, when he creates an object in the cluster, knows exactly on which OSD it has to store it, and the OSD knows on which other it has to replicate that object. So that's the central administration point to control the hierarchy in the cluster. One data center, multiple data centers, one host, one rack, 12 racks, whatever. That's what we represent in the crush map. A few design principles when we're talking about Ceph implementations. It's all about fault tolerance. If you have a storage in your environment, you want to make sure that whatever happens, you will not have data loss in the end. So we have to take care about fault tolerance. And taking care about fault tolerance means you can build the biggest cluster with a lot of fault tolerance. If your infrastructure is not fault tolerant, it's pretty useless. If you have one single switch that fails, and that's the only switch you have, the whole best cluster is worth nothing, more or less. So take care about the infrastructure. Regarding the monitors, in general, we start with at least 3 monitors. The reason is we need a majority decision if there are failures. And we have one OSD daemon per server, and we need to decide how many servers do we want to have and where do we want to place these disks and the OSD daemons. In general, one OSD daemon itself is just a single point of failure for the disk it maintains. But Ceph takes care of replication of data, which means if that disk fails, there are already other copies that can be used, and the failed disks will be recovered automatically on another, or the data of that failed disk will be automatically recovered somewhere else. Gateways, we have different gateways. We have the iSCSI gateway. For fault tolerance, we just implement that twice or multiple times, depending on your requirements. For the S3 protocol, we implement that also twice or 3 times. For iSCSI, we can use multipathing. And for S3 gateway access, we can use load balancers, layer 4 switches, reverse proxies, or similar technologies. When it comes to the topic redundancy, within Ceph, I can define how many copies of a specific object I want to have. Do I want to have 3? That's the default. Or more. That depends a bit on how my structure looks like. If I have 4 data centers, 3 copies are pretty useless. I need 4. But if I have 3 copies, the problem is that I always have 200% more capacity usage as a requirement. The alternative to that is we have a technology called erasure coding. You can think about that's a bit like a RAID. What we do then is when you store an object, we split these objects and create a checksum file in addition to it. And when we split, we can say how many splits do we want to have, and we can define how many checksums we want to have, and that defines how many failures I can have in the end. So the default is 2 + 1, which means I split an object by 2, create 1 checksum, which means I have an overhead of 50% instead of 200%. So that are possibilities. I have to decide what I want to do there. The redundancy is configurable. I can define the replication. I can define the erasure coding. And I can control the redundancy on topology, which means in the crush map that I mentioned already, I define the structure in my cluster, where are my data centers, where are my racks, etc. And based on that, Ceph takes care that, for example, if I specify I want to have 3 replicas, it knows exactly that if the first replica goes to data center 1, it creates the other 2 in data center 2 and 3. So the fault tolerance is topology aware. We have automated data distribution, which means you don't have to use disks that are all with the same size. So for each and every disk, there is a weight. And with the weight, we control that if you have 50% utilization in your cluster, each disk is filled by 50% more or less. So we automatically distribute the load automatically. Regarding performance, in general, there are three things you should think about. What bandwidth do you need? What latency is acceptable for you? And how many IOs per second do you need? In general, that defines your load scenario, your use case. And based on that, you can adjust the setup of your Ceph cluster so that it is based on your requirements. When I set up a big Ceph cluster, in general, I have the monitors. These are these M's. I have the OSDs. All these green things are these OSDs that represent the single disks. For CephFS, I have the metadata server. In this example, we have 3 of them. For metadata, I did not say much about it. In general, I have one primary active one and a second one that is standby. That's the current status. In the future version, we will have them active, but that's not yet the case. So at the moment, we just take care about fault tolerance for CephFS, but not real scale out with load distribution. But that will come up, Lars, in 5?
It's scheduled to happen in SUSE Enterprise Storage version 5.
Yeah, cross your fingers. Yeah. Different access protocols. So on the underlying layer, we always have the Rados protocol. On top of that, we have libRados. That's a library available for multiple languages. And on the top of that, we have the Rados gateway, for example, where we can connect classic applications that, for example, support the S3 protocol. We have RBD functionality as kernel module and as in librd, where we can connect Linux hosts and where we connect virtual machines directly. And on top of that, that's missing on this picture, we also have the iSCSI gateway. For CephFS, the client has direct access. This picture is also not correct. CephFS directly goes to the Rados layer instead of libRados. So these are the access protocols we have internal in the cluster. A bit about use cases. Originally, the major use case where the whole topic is coming from at the moment is in OpenStack. Ceph is one of the best choices for a storage backend. That is where the driver came from, where a lot of resources were invested in the past. So Cinder and Glance in OpenStack are able to use Ceph directly. Anybody here is using OpenStack? Also one, okay. The other ones should also have a look at it. Then we have the object store functionality. Depending on applications, there are different applications that can directly interfere with S3 protocol. Today, they can store, for example, at Amazon with S3 protocol. If you don't want to store it outside of your company, you can build an internal Ceph cluster and store your data there through the S3 protocol. We have the block device functionality with the RBD. We have the direct hypervisor access, so Xen and KVM and QEMU can access RBDs in the cluster directly. iSCSI protocol, I already mentioned that. Anybody here using iSCSI these days? Okay. Sorry? In general. In general. Fiber channel? Okay, and the other ones, nothing. Okay. Yeah, so, and we have the CephFS use case. In general, what you can think about CephFS, it gives you some sort of a access protocol similar to NFS. So if you have a scenario where you have several servers connect through NFS to one central share, more or less, CephFS can replace that. The major difference is the Cephfs is endless scalable. So with an NFS server, one day you reach the limit, either by bandwidth or disk size, whatever. With Cephfs, it's made to be endless scalable, up to the size of your cluster. And if the size of your cluster is reached, add a few disks, add another node, and you get more space. On top of the file system, we have a technology preview at the moment of NFS Ganesha, which is a scale-out functionality or a cluster. Help me, Lars. What is Ganesha? It's a
NFS Ganesha is the NFS gateway for Cephfs, so it's not necessary. It's not scale-out by itself.
It's not scale-out.
Gateway.
It's just a gateway. Okay. And Samba, we already can use RBDs, or yeah, we can use classic RBDs and put an NFS server on it, or we can put Samba on it, so that's already possible at the moment. Here we want to have a more direct integration because RBDs always have a bit more management requirements. I need another file system within the RBD before I can put Samba and NFS in it. So here we want to have a direct integration of Samba and NFS into Cephfs without the usage of RBD. So if you want to have CIFS access today, it's already possible, even without that, but in the future it will be easier. Some of the challenges we have with Ceph and a bit about expectation settings. I try to be a bit of a sales guy, but in reality I have to deliver on the promise because I'm the consulting going on site later on. And you have to be aware of that Ceph is very, very good in bandwidth, which means the more disks you add, the more servers you add, you get more bandwidth. So if you have high IOs, big IOs, large files, Ceph is going to be a really, really good thing for that today. When it comes to latency, so millions of very, very small IOs, latency is a bit of a problem within Ceph. I shouldn't call it problem, that's not the sales word. It's a challenge, but due to the architecture of scale-out, we always have more latency than a classical RAID 5 setup. That's just something you have to be aware of. That will be much better in the future. So one of the next releases will have a different internal file system instead of XFS. And when we have that, the latency will drop down dramatically. But today, latency-sensitive applications are not always the right to be run on Ceph. Another thing is, please do never start too small. At the moment, we recommend to start with at least 4 nodes when you're starting to play with Ceph. That's the minimum. We recommend to start with 7. So when you're looking into setting up a proof of concept or something like that, please do not use less than 4 nodes. And each of these 4 nodes should have at least 8 disks. So total system, at least 32 disks. The more, the better. Do not expect to have anything regarding performance if you're below that limit. Another thing is, as this is a totally new technology for you, at least that's from what I assume, when you're going to implement that, you should not switch your existing storage and all the clients overnight to the new storage that you have built up. You should put the load slowly on the new system and learn to deal with the new system, learn to understand it. Do not switch overnight. Put slowly load on it and learn with it. That's just from the experience we had. One or the other customer was too brave, switching overnight, and then didn't know how to deal with the system. So that's the background of that message. Yeah, so last point, give the system time to burn in and also yourself. Yes, that's a bit about the pre-sales phase. Now let's switch to the post-sales phase. Once the customer bought the subscription and I have to go to the customer, what is the approach that I'm going through a consulting engagement to make some sort of a success out of the implementation? And that's something I always want to mention again and again and again. If you do not think before you do something, the outcome might not fulfill what you require. So please keep in mind proper planning, proper prior planning prevents poor performance. And that performance topic fits very well in the Ceph environment. So how are we going to do that? The first thing I always do is I always have to understand the customer's environment. Before I design a Ceph cluster, I have to understand what does the customer have as infrastructure. Is there 1 data center, 12 data centers? What type of network technology is the customer using? Do we have 1 gig, 10 gig, 40 gig, etc.? And that's a minor point in general, and I would expect that everybody of you is already aware of that, but I realize in every implementation that this is not perfectly implemented. So please have a look at the time synchronization and name resolution. Also, Ceph is very sensitive regarding time resolution, time synchronization, and if the name resolution doesn't work properly, already the setup might fail. So that's the background why I've written that here. And depending on the clients that you want to connect, you should also be aware of the storage infrastructure that you're using and figure out what are your access patterns of the clients you want to connect to the system. Do you have write once, read many, or only writes, or what exactly do you want to connect later on, and try to figure that out. The more you know about that here, the better the design will fit to the to your requirements later on. And that brings me to the next topic. Figure out what requirements are exactly there. So in every fault-tolerant environment, you have to find out what is the RTO and RPO. Do you know what that is? Okay, recovery time objective means in case of a failure, how fast are you back? And recovery point objective means how much data loss is acceptable in case of a failure. So in the previous sessions, we were discussing about replication from one cluster to another. Not sure who was there. But the recovery point objective is something you're going to address with backup solutions. And the recovery time objective is something you address with fault tolerance setup of your cluster or multiple clusters. And you have to find out what SLAs you have to fulfill. In this case, SLA also means what bandwidth or performance requirements do you have to guarantee. And performance and scalability, how far do you want to scale? How much data do you want to store there? What performance expectations are there? After we have the information about the current environment, after we know what the requirements are, we are going to design the solution and select the proper hardware. When we're discussing about the hardware, we need to design about the number of servers, how many disks per server, how much memory do we put in the system, how much CPU, what networking do we use, etc. After we have ordered the hardware and the hardware is there, the next step is to implement all of that. I assume that, who is using SUSE Manager already? Only a few. Who is using automated server installations? Who is installing servers manually? Okay, all others don't install servers at all. Okay. In general, when I install a big cluster, especially when the cluster is going to be extended over time, it is very important to make sure that all servers are installed and configured 100% identical. I personally prefer the AutoJust method to install servers. There are other technologies available, so you can take whatever you want, but please make sure that you automate that and you eliminate the human mistake that can happen if you install multiple servers. Because if after 4 or 5 weeks you want to add one server to your cluster, if you did not have automated it, there is a very big risk that the 5th node in the cluster might look different. So that's the reason why I want to automate that. Another point is, please make sure that you have some sort of a staging system for your patches. So whenever you install the first server, when you patch that online, we as SUSE deliver a new patch every day. Which means if I install the first server with patches from day A and install the other one 5 weeks later, he will get patch level B, which is at that point in time online available. And then you have 2 servers in your cluster with different code level. That's not a good idea. So you always have to make sure that there's some staging in between. We have the subscription management toolkit or SUSE Manager. There are also other tools available. But please make sure to have something like that in place. And last but not least, it's very good to have some sort of a configuration management. You implement or you install the server, and then you change some configuration settings, and you do that manually. 5 weeks later, you might have forgotten, or depending on your documentation, you might not do it properly on the 5th node. And if you have servers different in your cluster, you will end up with a mess. You might run into performance issues, stability issues, etc. You always have to make sure that all servers are as identical as possible. And with the configuration management, we personally prefer Salt these days, but you can choose whatever you want and is running on SLES. Then, when we are doing the implementation, we always make sure that whoever is operating the cluster later on gets know-how. Because without having the knowledge how to deal with the cluster, depending on what the issue is, so Zhao will tell you a bit about that later on, you might do the wrong things. So the most of the downtimes I've seen in the last, let's say, 10 years were human mistakes, either in operations or in configurations or in, other human mistakes, whatever. So we always make sure that when we deploy the cluster, we also enable the customer so that he can use and operate that and react properly when something goes wrong. And last but not least, no cluster on Earth works as expected if I did not prove that by testing it. So most of the clusters I've built in the past, or I've seen in the past, when there were issues, we had that issues in areas that were not tested. So after implementation of a cluster, it's required to test it. In case of Ceph, we have 2 test scenarios. One test scenario is the fault tolerance, which means we need to unplug cables, replug cables, power off servers, things like that. And in all the test cases, we always document them. So first I write down how the test case looks like, then I write down what the expectation is, then I execute the test and document the results. Only after doing the tests, I can be sure that the infrastructure and the cluster works as I really need it in production. And that's the fault tolerance part. On the other hand, we also have to take care about the performance part. Once you have all your clients connected to the system, it's difficult to test if everything is working because you will always impact your clients. So before attaching the clients, we're doing a bottom-up testing, which means I'm testing the disk, I'm testing the object storage daemon, I'm testing the RAID-OS gateway, I'm testing the iSCSI gateway, up to if I have VMware connected, I test VMware, the performance, and I test the virtual machine guest performance. So from bottom to up, and the same is true for the network infrastructure, I test the latency and the bandwidth for all of them. I document that, and once I run into an issue, I can look that up and compare with what's the current situation. That's why we do the bottom-up testing and document that. So that's what I wanted to say. No cluster is working as expected if you did not prove it by testing it properly. A few real customer setups. So most of the customers these days are not brave enough to buy a very big cluster on day 0. So I personally didn't have a customer buying a 1 petabyte cluster today. So it's most often the other way around. They try to start as small as possible to keep the cost low. And then from there, they start increasing the size. So the customers I have been dealing with, most of them started with 4 nodes or up to 9 nodes. The 9 nodes were, for example, at a customer that has 3 data centers. So this customer put 3 servers in each of his 3 data centers. And we always start with 3 monitors. Normally, you do not need more. I think maybe when you have 1,000 OSDs, you can add more, but please make sure to have always a odd number due to the majority decisions we require for failovers. We require at least 4 servers, and we add the additional gateways depending on the access protocols the customer is using. The more disks and the more servers, the better that is for Ceph. So if you can have more, please use more. Ceph really pays off in big environments. The bigger the environment is, the cheaper and the more bandwidth you will have. A general thing, please use 2 GB of memory in a server per terabyte of storage that you have. There might be scenarios where you might need more. For example, if you would have only one OSD in a server, 2 GB of memory might not be sufficient. But in general, that's the rule we already have in the documentation now. And you should have 1.5 gigahertz CPU per OSD daemon. So with that numbers, you can calculate how much hardware you have to put into the server, how much memory, CPU. A few points. The more memory, the better it is. This is the minimum requirement. But if you have a chance to put more memory into the servers, Ceph is automatically using the page cache of Linux for read operations and read caching, which means if you have more memory in the server, reads can be faster. It always depends on your use case. If objects are not read more than once, then it's useless to cache. But the more memory, the better it is. And regarding the CPUs, if you're using erasure coding, it makes sense to have faster CPUs because erasure coding is CPU intensive. I have chosen 4 customers from the last implementation that I want to just give as examples. So customer number 1, that is a hospital. And this hospital required a storage system for backup purposes and for long-term storage. The long-term storage was required for X-rays. So if you were there to X-ray your arm or whatever, they have a place to store that data. They have a system which is running on Linux. No, it's not running on Linux, but it's using a Samba server to access that data. And for that area, they wanted to have a storage system that is as cheap as possible and can scale out endlessly because these X-rays are very big. And they might need to store them for maybe 10 years, because if you come again there with something else on your arm that was broken, they can look up that picture after 10 years still. So that's the reason why I want to have a scale out and cheap storage. They decided to start with 4 nodes, and they have only put spinner disks, SATA disks into these servers. When we have set up the pools, on the pool level, we create where the data is stored and what the replication layer, or what the replication should be later on. They had created 2 of them, one with replication 2 and one with replication 3, because that impacts the cost of the data that I store in there. Normally, we recommend with 3, but 200% more capacity is more cost, or costs more than just 100% more. They were using a Samba server, using an RBD. Oh, and by the way, they also connected the EMC backup solution they were using to this system to store their backups from EMC. It's Legato Networker, right? Legato is now EMC. Yep. So the Legato software is now storing their data via backup to disk functionality directly in this cluster. The funny thing was, in general, we recommend to use 10 gigabit at least, but they were also happy with 1 gigabit access for the clients, was sufficient for their environment. One thing I didn't mention so far, when you set up a Ceph cluster, you can divide the replication traffic from the client access traffic on the network layer. We say public network for the clients, where the clients are talking to the cluster, and we say cluster network for the replication traffic, where the OSDs talk to each other to replicate data. And we always recommend to have more bandwidth on the replication side of things, because if I write in 1 gigabyte, and I need to replicate it twice, I have the double traffic effort on the back end. So that's the reason why we want to have more bandwidth in the cluster network. The second cluster, or the second customer that we have here is, that was a really interesting thing because that customer wanted to have his ESX environment where he is running SAP HANA in virtual machines hosted on Ceph. And the only thing we did there is we were experimenting with 3 different architectures. So the number of disks was always the same. In each and every server, we had a set of SSDs and a set of spinning disks. And we tried 3 different scenarios in this setup. One was with cache tiering. One was with erasure coding. And when you're using erasure coding in RBDs, you have to use cache tiering. So in this setup, we created 1 cache tier with the SSD disks and 1 backing storage with erasure coding. And in the second setup, we did not use erasure coding. We just split the data so that fast VMs could rely on SSDs and slow VMs could rely on spinners. And in the last setup, we tried to do a bit of a mix of that. The interesting part here is when we were experimenting here, we could do all of these changes live and online. So it was possible to change everything while ESX was connected and the whole system was up and running. This was a test system, to be fair. This was not really productive. But I want to outline here that with Ceph and with the software-defined storage approach, we are able to change architecture and design in the running system and operate on the open heart whenever we need to do that. Another example, customer 3 was just using Ceph as an OpenStack backend. And finally, we had one customer with the 3 data centers that was using it for everything. They had an application that was directly supporting Ceph with C-Life or something. I can't remember what that is. And they are using a mix of everything. They have SSD pools, they have erasure coded, they have cache tiering, no cache tiering, different replications, etc. So I just wanted to tell you, this is the whole picture. We can do everything with SUSE Enterprise Storage. And with the 4 examples, maybe your use case fits in one of the other later on. A few lessons learned. Whenever you buy hardware, please make sure it's SUSE Linux Enterprise certified. You can take whatever hardware you want, but if you're running into an issue, our support might ask you for, is the hardware certified? If it's not, we cannot guarantee the stability, that the drivers work properly, etc. And we already found issues in different areas where the customer decided to select a network card that's not certified. There are good reasons why we thought about that. Memory CPU, I already mentioned that. Another thing, if you think about adding as many disks in a server as possible, several servers allow to use internal modules for with SD cards or SDOM modules where you can install the operating system too. We do not have too much good experience there. So the SDOM modules might not be as reliable as SSD disks. So if you have a chance, please try to use SSD disks instead of the SD card I thought I had written SD card here. Okay. Do not use internal USB sticks or internal SD cards to install the operating system. Use SSDs if possible, or spinner disks, small spinner disk internally. RAID controller. Because Ceph is doing the replication between the servers, it's not really required to have RAID controllers in the servers. Our recommendation is to not put RAID controllers in your servers, and instead of doing that, use the money for more CPU, more memory. Because there is no real value of the RAID controller functionality within a Ceph cluster. Make sure, depending on the hardware you select, there are some incompatibility issues between SSDs and different host bus adapters. So not all combinations work perfectly, and please use enterprise SSDs in all scenarios, otherwise they might not run long enough as you might need it. Yeah, mainboard setup, I think I skipped that. You get the slides anyway. Network infrastructure. Ceph is very sensible regarding the network communication. If you have a network problem, that can cause really, really big problems in your cluster. We had that, for example, with a corrupt or with a problem with a network card driver. So please make sure that there is no single point of failure in the network, and use proper hardware, proper drivers, latest drivers, etc. Use separate networks, I already mentioned that. If you add iSCSI to the picture, also for that you should use a separate network. And yeah, the other things, I think that we are running a bit out of time. 10, yeah, but that's his 10 minutes. When we're creating pools, you define the size, which is the replication level. And you have to make sure, or keep in mind that there are also background processes going on. If there are failures, we will have backfill going on, and we have scrubbing in the system, which verifies on a regular process if the data that you have stored is still consistent. So that there will checksums will be created, they will be compared, just to verify if your disks are dying slowly and bits are changing, things like that. This is impacting your client access performance. So when you're testing your system, you should not test it when it's empty, because then you don't have much of these background processes going on, and that's something you should keep in mind. Regarding cache tiering, I mentioned a few examples before. We have customers using cache tiering. At the moment, we recommend to avoid cache tiering when you do not really require it. Why? It's very complex, and cache can slow down a system if it's not set up properly. So we had scenarios where adding a cache tier slowed down the whole environment instead of improving the performance. So please implement cache tiering only when you know exactly why and how to do it. Fault tolerance, make sure, no, I think, one important thing I want to mention regarding the fault tolerance. I mentioned we have the requirement of 3 monitors. If you only have 2 data centers, that's a problem, because you have to put the 3rd monitor in one of these 2. It is a good thing to have a 3rd place then where you can put this 3rd monitor. So some customers have a backup room or something like that where you can put that, but make sure to have that 3 also in 3 different places. Okay. That's, I think I skipped that. One word about the IOs per second. At the moment, each and every write operation causes multiple IOs on each and every, or on the disk I'm talking to. That means if you buy a disk that can handle 1,000 IOs per second, you might only be able to use 250 out of these. That's going to change once we introduce the Blue Store in one of the next releases. But keep that in mind, if you have IOs per second requirements, that this is not very good at the moment because not as good as it will be with the Blue Store. Okay, finally, you get 10 minutes. Our best practice is, before you're going to put the CD in the server, please create some sort of a concept. Think about what you're going to do, how you want to design it before you're implementing it. Ensure repeatable installations, AutoJust, subscription management, toolkit, staging, etc. Use configuration management technology. Install the latest and supported drivers, depending on the hardware you're using. Make sure that you're testing the fault tolerance. Make sure that you're testing the performance. A word about tuning. Please, please, please do not start tuning right after the implementation. I've seen so many scenarios where a customer changed parameters without really knowing what he's doing and why he is doing it. Every parameter has positive effects and also has negative effects. So when you're going to tune, please let the system settle a while, work with the system, and start tuning later on. Our best practice at the moment is not to tune at all, because with each and every version upgrade, we have so much performance increase that investing time in tuning and testing it again, and tuning and testing it again, is just a waste of time. And finally, think about the documentation. And with that, thanks for the time. Any questions so far? Yeah, please.
Can we have Excel match virtual VM and servers in the same cluster to run it?
Sorry, I'm not sure if I understood the question. Is the question if we can have different types of servers within the same cluster?
Like virtual machines as well as physical machines?
Like virtual or physical machines. In general, within a Ceph cluster, for the OSDs, I only want to have hardware. I don't want to have an OSD virtual. Regarding the MON, we can discuss if it makes sense to have that virtualized. I'm not sure, what is your opinion on that, Lars?
My opinion on that is that eventually it will be containerized, which will be a lot better, but in the meantime, one of the MONs could certainly be virtualized, but you already have plenty of physical hardware for the OSD, so you might as well run the MON there.
Yes, for gateways, you can do them virtualized, no problem about that. It's just a question if it makes sense to have an iSCSI gateway virtual running in VMware, and VMware having the data store connected to that iSCSI gateway, then that's the catch-22 thing, you know. Okay, any other questions so far? Okay, then I will hand over to Joao. Okay. Sorry for stealing your time.
That's fine. Okay, so after Martin's presentation, we basically have a setup cluster and all of that. And in an ideal world, we will always have an healthy cluster. Every single time, it will never have an issue. But sometimes the cluster health will eventually shift to some not as healthy state. Most of the times, it will just be warnings. And warnings can simply, well, they do not cause necessarily unavailability of your data, and most of them are transient. But still, if they are sticking and they are not going away, you should handle them as soon as possible, because warnings can easily translate into errors at some point. With errors, this does not mean that the data will be unavailable, but sometimes that's what happens, and they are less likely to actually be transient and go away on their own. So the question you have to ask yourself is, what actually caused this? Were there any power issues, for instance? Do you have some nodes that are still down or being booted? Did you suffer any network issues? As Martin stated, Ceph can be sensitive to network problems, and that may cause some havoc in the cluster. Did you add any hardware or removed nodes? If so, did you forgot to change the crash map, or did you actually change the crash map and it didn't go well? All these things can affect the health of your cluster. Sometimes the warnings and the errors you will get are due to some monitors, to the monitors, and they can be, for instance, that one monitor is down. If that monitor is down, why is it down? Can you restart it? If it cannot be restarted, it may be because the monitor ran out of disk space and it's refusing to start. Other common warnings, especially if you are just booting your cluster, you may have clock skews. The monitors may report having clock skews, and given the monitors are really dependent on good timekeeping. Wait, what? Okay. Given the monitors are, the monitors do require the clocks to be in sync, and if they detect that the clocks are phased by a few milliseconds, they will report warnings. These warnings usually go away unless your NTP servers are misconfigured or the monitors are unable to reach them. Sometimes the monitors may appear to have frequent elections. These may be due to the clock skews, because again, the monitors are sensitive to the clock skews and latencies and all of that, and sometimes frequent elections may be a symptom of bad time tracking or huge latencies on your network. Sometimes, and this is the worst case scenario, the monitors are out of quorum. And in this case, you may not even be able to get the cluster health because the monitors are just not there. In this case, assuming you have all your monitors up, usually this is a network issue. The monitors are not able to communicate with each other. They're not able to form a quorum because there's no elections going on. And usually in these cases, either it's the monitors that are down or they just cannot reach each other. On the OSD sides, if you have down OSDs, can you start them? If not, these may be because, for instance, you had a power failure and some disk got corrupted and the OSD is refusing to start. The logs will tell you more about this. If the OSDs keep dying, you restart them and they keep dying, this may be because you don't have enough RAM, and the OSDs may be trying to recover, and during recovery they will consume a lot of RAM and they may just be killed by the kernel. Also, again, Ceph is sensitive to network issues, and some network issues may cause the OSDs to consume a lot of memory and again be killed by the kernel. On the other hand, it may just have been that someone set a no-up or a no-in flag on the OSD map, and a given OSD that was down now cannot get back into the cluster. But again, most of the, and these are actually the most common issues that we've seen. Warnings about placement groups. Placement groups not being remapped, or placement groups that are down, degraded, incomplete, or unfound. These are usually because an OSD is down. Some of them will not cause data to be unavailable unless the PG is either incomplete or unfound, in which case usually it's because a given OSD that holds the data is down and the cluster hasn't been able to replicate the data or does not have a single copy of that data to serve to clients. Having PGs down, again, it's because the OSDs are down and there's no place to actually find them, degraded PGs are the most common state of a PG when you have a warning. And it only means that the cluster needs to replicate that data. And usually these are transient. You will see them as degraded while the cluster is replicating the data. Often, not so often, but it's also common, you will have operations that are stuck. And this, again, is everything tends to boil down to you have down OSDs. Or eventually you may have the wrong crush rules, and this will cause these, the PGs to not be able to either be remapped or replicated. So these are the things you actually need to look for. Do you have wrong crush rules? OSDs down. Again, the OSD map flags. If the OSDs are not able to talk to each other, they will not be able to replicate your data. So you will not be able to move away from a degraded state or an incomplete state. If OSDs are overloaded, for instance, they don't have enough RAM, or they are recovering you. If you are trying to recover a whole rack of OSDs that are under-provisioned, the OSDs will likely be overloaded and you will not be able to recover as quickly or as painlessly as you would expect. But again, if everything fails, if you are not able to assess the causes or why this is happening or how to solve it, you can always contact support. For a speedy recovery, we would appreciate that you tell us as candidly as possible what actually changed and ship us the support config and logs from the affected nodes. When it comes to logs from Ceph, the default settings have the log levels at 0, which will only report really critical errors and nothing else. So in these situations, they are close to useless. We will need you to increase the debug levels. I know these are not the most obvious and the easiest to remember, but just ask, we'll tell you. Set the debug levels, get the logs, send us the logs, and we will look into it. And we will try, well, we will eventually fix it. That's it. Setting the debug levels is painless. You can just inject this on the fly with the cluster running, and yeah, that's it. And yeah, I'm finished.